Welcome, especially at this time. You know, security after lunch, I don't know, we'll all be dozing off. But I'll try to make it interesting. I'll try to make it more fun so we are all, focused on the topic. I'll be talking, of course, about security, but the way we like to articulate security for IoT is its trustworthiness. So, of course, that term has been defined a number of times by the industry, by people out there, and it really means it is secure, it is private. Can I be assured of its safety? And that is important for IoT. Can I be assured of its reliability? So those are all terms which get together, and then we start talking about trustworthy IoT. Now, as I like to say, security is never a goal. Security is always a journey. We are on a journey. There are many things that happen in that journey. Our attackers become much more sophisticated progressively. They know more about what to do. The reward for attacking infrastructure becomes much more, and so people get more sophisticated. What we are seeing now is also attackers are not kids in a garage who are trying to play around with infrastructure. These are highly trained, highly motivated, perhaps even state actors who are trying to bring down infrastructure, especially in the case of IoT, because IoT is not just bringing down a database and stealing some secrets, it's about shutting down countries, right? It's about shutting down countries. And so the motivation to attack IoT infrastructure is extremely high, but so should be the motivation to protect IoT infrastructure. So that is something that I want to talk today. I am Arjuman Samuel. I am the security lead for Azure IoT. We do a number of things, both in terms of the features we provide, but also in terms of some programs, in terms of working with partners, working with customers. So there's a bunch of different things we do for IoT security. And I'll actually go over some of those just to give you a flavor of where we are in all of that. I also have some part of my presentation is fairly technical. I'll go into that. Stop if you feel it's too much, or if you have questions, I'll be happy to answer. I'm sure you have heard a lot about IoT today, yesterday, and the day before. Yes, IoT is really delivering results, and we see that all the time. Our customers who have started to adopt IoT are going from where they were in the 20th century to where they need to go in the 21st century. It's a driver for business transformation. And there's a lot of motivation from our customers to actually go forward. It requires some changes. I mean, it's not as easy. While the outcome is pretty good, you probably have new monetization streams, you probably have new ways of doing business, you probably understand your business processes better with IoT, but it requires some changes in the way we do business, in the way we organize ourselves. So those organizational changes, as well as processes, some tools, some new ways of thinking are required. And these are fairly large security challenges. These are not trivial. But what I'm going to stress today is, given the right best practices, the right procedures, the right features that we provide, these challenges are not as big that anybody cannot go through them. Anybody cannot just secure themselves. Today I'm going to do that. And while I do that, I'm actually going to make a claim. And the claim here is that Microsoft is leading the way in IoT security. Right from the whole stack, we are actually making huge strides in IoT security. And again, I'm going to prove that claim. There are so many things in play today that we as Microsoft have put in place, along with our partners, along with our customers, put in place so that we all are together leading this IoT security way. So that's my goal today. I'll talk about that. But how I'm going to do that is, first I'm going to talk about how do you gain leadership in IoT security. There are a few things here. One, of course, you think about IoT infrastructure end-to-end. You cannot think about IoT infrastructure as only the cloud or only the device or only the connectivity or only the gateway device. They're all connected anyone which is not secure compromises your whole network. So I'm going to make a case for an end-to-end IoT infrastructure and how you secure it. I'm also then going to dig a little bit deeper in our hardware-based secure design for IoT security. And this hardware-based secure design is actually driving a few standards. It's changing the industry. It's a low-cost way, comparatively, a low-cost way of getting more security. Who doesn't like that? Right, so that's what we are trying to do here. I'm going to talk more about it, but this is a standard we are pursuing. There is now silicon available. I'll talk about that as well for this model. Then I'm going to go deeper into, given all of this conversation, how can this be real for our customers? And we have a bunch of different things happening in that space, making, for example, auditing, evaluation of infrastructure, and so on. And what do we provide there to help you do that? And finally, there's a lot of work that we do in standards. One standard I described, which is our hardware-based security standard, which we are working on, and I'll go into detail. But also standards like a security maturity model we are working on. I'll go into detail as well. And again, we are expanding the envelope of the security industry here. So I'd like to share that with you. And there's a lot of work that we do as a company with regulations, so regulators, so governments. So IoT security or any security is as good as people out there who enforce it, right? And the unfortunate part is that many governments all over the world have different standards of how they enforce security or privacy or safety and so on. So we try to work with all of them. We have a pretty large team of people who actually do this work, who go out and interact and understand what's going on in that space, regulations, government policy, and try to be the force of reason, as we like to call that, in that conversation. Try to talk about actual customer scenarios that we see, actual customer challenges that we see, so that they are actually solved in those conversations. So this is kind of a rundown of what we'll talk of today. I'm not going to give you a complete rundown of what Azure IoT is. I'm assuming that you guys already know what Azure IoT is. I'm not going to go into details, but just in quick 1 minute, Azure IoT Hub is a service, different devices, multiple platforms, different kinds of devices can connect to that service. We provide a bunch of features to enable that. We have open source SDK libraries in many languages for multiple platforms which go onto devices, connect to IoT Hub. IoT Hub not just allows you to scale with data which is coming in, but also to do commands back to devices and also to manage these devices. You are able to manage firmwares, you're able to manage state, and so on from IoT Hub. So IoT Hub is one place where you can actually have a scaled deployment of IoT devices securely, as well as to manage them securely. It is also a gateway to the rest of the cloud. If you want your data to then end up in storage or machine learning or elsewhere, IoT Hub allows you to do that. So really, that's our whole infrastructure. But the way we think about security is in these three pillars, starting from device security on your left, to the connection security in the middle, and then to cloud security on the right. Talking about device security, there's a bunch of things we're doing in that space. Of course, secure device management, I very briefly described that. It allows you to capture the state of the device and keep a copy of that state in the cloud. And since now these are two states, the state of the device on the device and state of the device in the cloud, we call them twins. They're twins to each other. And the infrastructure takes care of syncing that twin. So at any given time, you can come to the cloud and you can see the last known state of the device. You can also change the state of the device. You could go to the cloud and say, I want this device to go to firmware version 1.3, define it in the cloud. We in the underlying infrastructure take care of changing that state onto the device, and then the device manufacturer implements that change in firmware. So device management done securely is part of our value prop that we provide. The second thing over here on the device side is device provisioning service. Provisioning a device, IoT device, and provisioning them at scale is a huge challenge. Right now, you would have to actually take a device, read off some key, or put some key on it, and then say, okay, now this is on the device, and now it connects to the right place. So we are making that easy. We are making that, and how we call that is zero-touch provisioning. The device is born somewhere. Of course, it has some hardware characteristics to it, like it has a security element on it where some keys are stored. And now, based on some enrollment you do at manufacturing time in our portals, you switch on the device, put on the network, and the device simply connects to the right place in the cloud. You do not have to do anything on the device. That's something that we released in preview a couple of weeks back. It's called Device Provisioning Service. I'll encourage you to go and see that. And the goal here is to make device provisioning as simple as possible, but also to do it for as many different kinds of hardware as possible. Depending on what kind of hardware security you have, secure element you have on the device, we have a way to support that. Which brings me to the third point here, a diverse set of hardware that we support. I'm going to talk about DICE, which is the Device Identifier Composition Engine. I'm going to go into detail later. But we support TPM, we support DICE, we support a bunch of other hardware security elements. And we have architected our device-side SDKs such that you can include any hardware that you have, as long as there is some basic functionality in that hardware, some basic security functionality, like crypto, like secure storage, and so on. How we have architected it is through an auth API layer, and you plug into that auth API layer, and our SDKs work on top of it. So that's really support for a diverse set of hardware. We also support a cert-based identity, X509-based identity. As long as you have the private key on the device, there's a cert which is signed by somebody. You can trust that, and now you can start authenticating. So that's just on the device side, and just a partial list. We do a bunch of other things also, but this gives you a flavor of what we do on the device side. For connection, connectivity always has to be standard-based. Otherwise, really, there is no connectivity, right? So we support TLS 1.2, X509. We support a bunch of secure protocols at the application layer, AMQP, MQTT, and HTTPS. All of them are secure. So that's really to secure the connectivity between the device to the cloud. Now, once you reach the cloud, there are a bunch of additional features that you get in the cloud. There is monitoring through Security Center. There is Azure Active Directory, which allows you to give permissions to your users based on role-based access control. There is Key Vault, which allows you to save your keys. There is policy-based access control of devices, so you can define which device is allowed to do what, and based on a policy, and we have a set of policies you can apply on these devices. And there's a bunch of controls such as IP, whitelisting, blacklisting, and so on. Now, when you put all this together, it creates a bunch of features which you could use to secure your IoT infrastructure end-to-end. Now, imagine if you were only to concentrate on the cloud, and you would have configured the cloud to be the most secure cloud, which today it is. But then you have not thought about the security on the right side, on the device side. You might have a device connected to the cloud, which is sending poison data, bad data to the cloud. That cloud security doesn't matter then, because your data is not what you want. Similarly, you could say connection security. If you have not worked in that area or done something there, people could be simply coming in and either changing data or reading data off of the connectivity. So unless you think about the end-to-end security for this infrastructure, your infrastructure is really not secure. And we provide all these different features which enable you to do that. So here is one example that I have, if I can move this. This is a blow-up of a IP camera. And there's a reason why I picked an IP camera to give an example of how device security is essential, right? How many of us have heard of Mirai? Right? So Mirai was a malware. Actually, last year, October or so, it surfaced. It took over a bunch of IoT devices, including cameras. That's why I picked it up. Cameras and DVRs and routers and so on. and it used them to create a distributed botnet. And then that botnet attacked the infrastructure of the internet, right? The DNS servers which actually serve the internet. And it brought it down. It brought down some well-known sites for that time when it was active. So the reason was because the attack vector there was that device manufacturers who were creating these IP cameras or DVRs, they had not thought about, hey, there is an admin password here, and I want to change that admin password beyond blank. So there's a list of 18 passwords which are in Mirai malware. It would go out, ping the device, and see if any of those would apply. And 90% of the times, those default admin passwords have never been changed. And it was able to take over the device and install the malware. So anyway, that's how the malware got on the device. Then it started pinging. These are all IP-enabled devices, started pinging and bringing down the whole infrastructure. Two things that I think of when I think of Mirai. One, I haven't seen a mass recall of these devices. Right? These IP cameras, DVRs, routers, which were used in that attack, still out there. I haven't even seen them being updated. Nobody has called somebody that, oh, I need to come in and update. Well, one, because these are $100 devices. These are not $30,000 cars, which are usually recalled. So these devices are still out there. And it's only a matter of time when somebody else gets up and starts using it in some other DDoS attack or something like that. That's one. But the second thing, more troubling for me, is that the whole Mirai infrastructure, including the botnet and the command and control system, is open source now. If you know where to look for it, you actually can get the source code of that whole infrastructure, put it on your machine, and start looking for such devices and deploy. I mean, please don't do that, but that is something which is now possible, right? The barrier to doing that is extremely low now. It's all open source. So, which brings us to the point I'm trying to make here. Devices which we deploy off the shelf, we do not know anything about them. We do not know what OS is on it or what derivation of the OS is. How secure is the OS? How secure is the silicon? Are there any back channels left on the silicon or not? Can you perform remote updates, over-the-air updates? Or is there even an infrastructure to orchestrate that? So, and then, of course, physically, can somebody open this device? Obviously, people can, but are there safeguards which detect tampering and then shut that device down? So if you have actually answered no to all of these devices, we have, to all of these questions, you would find that there is a huge hole in your end-to-end infrastructure if you're using any of this. And this is just one example. This is just one example. As I usually like to say here is, an IoT attack, or for that matter, any cybersecurity attack, is not a matter of if. It's not a matter of if. It's really a matter of when that attack happens and how prepared are we together to weather that attack. So that's really my message here. Some of the devices we deploy off the shelf they might be good, but some of them are not. We need to have much more diligence in terms of understanding how that works. Now, if you take this device and connect it to the most secure cloud in the world, all bets are off. Nobody can assure and guarantee anything there. So my case for end-to-end security is right over here. We need to understand that unless we think end-to-end, unless we bring everything together and then think about IoT security, it simply does not make any sense. But then those challenges are even worse when we start thinking of brownfield. Imagine all these manufacturing plants and all this infrastructure out there, which has been put in place for the last 15, 20 years. Imagine the design. It was never designed to be connected, and now we are all connecting them together. So brownfield is a huge challenge. No time soon you will find billions, if not trillions of dollars of investments being thrown away and new devices brought in. You have to retrofit. You have to think about attack vectors on these old devices and machines. And that, in our experience, is also one big challenge when you start thinking about end-to-end IoT security. Yes, I can stand by the security of the cloud, but unless this is secured, it doesn't matter. Okay, so what did we do for that? Going back a little bit, I have scared you all enough, right? So there are bad things happening out there. We need to do a lot in this space. What do? We started taking some steps in the last couple of years, and we started talking to our partners, customers, and trying to understand how can we impact this end-to-end security. And one thing that we have done a number of things. I'll actually talk about all of those, or most of those. One thing we did was we put out an industry best practice document. I'll give you a URL to it. It's a paper out there. It's a growing paper. I mean, it's a living paper. What we did was we said that the first thing you need to do is think about the people whose hands touch this end-to-end infrastructure. It's not just the device manufacturer. It's not just the people who develop the solutions. It's not just the people who actually deploy and operate. It's everybody. And so we divided them into these roles. It could be one person with all these roles, or 4 people with these 4 roles, or 10 people. It doesn't matter. Essentially, the message here is there are these roles who actually go in and make the IoT infrastructure a reality. And then what we did was we put together some security best practices. And over here, I just have a few sample best practices that we put out for our partners and customers. And this is all out, so anybody can actually use it. So for example, I'll just pick 1 or 2 here. Hardware manufacturers, going back to that IP camera. When you develop hardware, are you scoping it to the bare minimum hardware requirements or not? An example there is a USB port. Do you really need that USB port on your device or not? Or can you live without it? Because USB port has been proven to be one of the best or the worst attack vector in this space. So that's one advice we gave. We did a lot of study on that, and we realized that unless you scoped your hardware to that scenario, you are actually creating a monster, which you have to control later on. Now, the one thing we heard, and I'm sure many of you are thinking about it, you know what? I'm future saving myself. So the hardware that I ship today, yes, is not required all of it for my scenario today, but maybe in 2 years' time, I'll update it with some software and new things would light up. Yes, if that is a long-term goal, then we need to think about them as secure steps as well. Can we shut off that part of the hardware and not? You know, there are all these techniques out there. We need to invest in it. Tamper-proofing is one. Building security in hardware. So security elements which have your root of trust on the device is another thing that we recommended, and not just recommended. I'll actually go into more details for this, and I'll tell you why we and how we actually design something for it. Solution developers, you know, if you are a solution developer, you need to think about so many different things. For example, by the way, all of our stuff client side is open source. We play a lot in open source. But if you're using open source libraries, are they supported by the community? Is somebody looking after them, updating them over a period of time, right? So all our libraries, we try to do that in open source, but is the community doing that or not? So that's another, you know, example best practice we have. Operators have a lot of weight on their shoulders. If you think about the best practices they have to go through. They have to keep the system updated. They have to keep monitor and detect any malicious activity, and so on. So there's a bunch of these best practices. I just picked a few. And the URL is, if this will come up, there you go. ak.ms/IoT best practices. There's a paper out there. I recommend if you are thinking about infrastructure security, this is a good starting point. Okay, so now I get into our hardware-based design work that we are doing. And I'll talk about the different things we have done, as well as some new things that are happening right now. But before I do that, it's important to understand the threat landscape for hardware. And when I started thinking about this, some very interesting threats emerged. And I just like to share them with you. And some of them are very specific to IoT. right? And imagine that IoT is also about deploying your sensors, your gateways, and so on out in the wild. They're not in a data center, which is protected by a guard and walls and all of that. This is a gateway in a mall somewhere, where anybody can have access to it and steal your keys off of it. So when I started thinking about it, we came up with these threats. So there's a lot of non-standard security out there. People have cobbled together things which, yeah, work in some scenarios, do not. But that creates an environment where you cannot then justify or you cannot then design based on standard practices like secure boot, secure update, secure storage. All of those things need to be standardized as much as possible. And that's not happening there. This one is interesting. The skills to attack infrastructure, interestingly, is getting better and better out there. Just two examples here. One of them is whenever a device fails, by the way, the story of Mirai that I just described is published, and a lot of people have done studies, but that also gives people information to go and use that infrastructure and kind of, makes that easy for people to learn that. So the failure reports and the failure analysis that people do also creates an environment where people learn how to attack infrastructure. The second one is interesting. I never thought about it. There's a bunch of patent litigation happening out there, which is looking at the security of products. And believe it or not, there are people who follow that just to know what are the loopholes in a device which they can exploit. So I'm not saying we shouldn't do that. What I'm saying is that those are vectors for which we have to be careful with. Physical access, as I mentioned, you are deploying IoT out there. You're deploying it in the middle of nowhere on a pipeline. So what kind of environmental tempering are you doing for that or protecting against? What kind of analysis do we have? And what kind of testing we do with fault injection? So those are some of the things to consider here. This is also important. When you think about heterogeneous compute environments, meaning all these different architectures, all these different operating systems, and I actually argue there are infinite operating systems out there. Infinite because you can take an open source operating system and create your own version of it, and hence there are infinite operating systems. So how do you protect against this heterogeneity? There's also different vendors doing different things and different use cases that they have, and then they put different capabilities on each device. So that's a challenge. Then, of course, the development environment doesn't help. Some of the code is compiled, some is scripted, and in some cases, it's mixed. So how do you protect against mixed code where there's a C library, underneath there's a machine code, and then on top is some high-level language like Java or C#. So the protections against all of those are different. So considering this threat landscape, we came out with a paper with a list of properties. We call them the 7 properties of highly secure devices. I would recommend if there's a URL over here, ak.ms/7 properties. I would recommend there and if you could get access to it and read it. It's all open, so you can read it. These are well understood security properties. It's not that we have invented some new security property suddenly. These are well understood. The research community and the security community has been thinking about it and document these properties for a while. But what this does is it puts it together in a form which you can actually relate to IoT. You can relate to your device infrastructure that you're creating. And the key here is, the key elevator pitch for this paper is that it is based on hardware-based security and software which evolves over time securely. Right? So that is really, if you think about how do I create a highly secure device for IoT, this is how you do it. You root your security in hardware, in whatever hardware mechanisms you want to put in, and then you take software on top of it, which should be secure, but also it should grow securely over time. There are a few properties here which are kind of interesting to mention. The first one, of course, is the hardware-based root of trust. I think that is one of the key properties, and hence it is #1 property. You cannot trust a device which does not have a way to identify itself securely. So hardware-based root of trust, which in our normal world would be TPMs and the like, give you that capability. They give you that capability to put a private key in there which is immutable, undiscoverable, right over there on the hardware, and then that can be used for establishing trust with somebody. So that's the first step. Keeping your computing base as small, and because then you can trust on it and you can also monitor it, is important. Many architectures today actually support this, a small trusted computing base through trust zones and so on, and those are exploited when you create these secure architectures. Now this third one, which is defense in depth, is as old, perhaps, as old as we humans, right? Because when we became human, we started fighting. And when we started fighting, we started putting gates and doors and moots and soldiers and so on. And when we started doing that, what we were doing is we were creating defense in depth. So when the first thing went off, there was a second door and the third door, and then a soldier and somebody. So defense in depth is another strategy for protecting your devices. So you need to put multiple layers of security on the device so that when one is compromised, you go into the next one. Compartmentalization as well, the way I think about it is modularization. So if you look at your device, if you could modularize it as much as possible so that you can actually control the security features of each module, helps you. Now again, coming back to our conversation about security being possible or better when you have a standard-based approach. So certificate-based authentication is the way to go here. Certificate-based authentication also allows you to go away from simple shared secrets like passwords and all, go to a certificate which is on the device, and then you use it for your communication. Renewable security is extremely important. When you're designing your device, you need to think about how that device can be renewed, can be updated securely, right? So it has to be updated securely, and then it has to be assured that that device is in that state. Which brings us to the last one, which is failure reporting. So the device should be able to detect when bad things are happening around it. When somebody brings in 2 probes and starts going into the memory or the memory bus, the device should be able to detect that and go into a reboot or at least send out some tampering signal. So those are some of the, those are 7 properties. There's a paper over there. I would highly recommend that in case you're thinking about device security. It's a great read. But just so you know, these are well understood principles and practices. We have just put them together more in the context of IoT devices. Okay, so now I'm going to talk a little bit about design of secure hardware. And I'm going to go a little bit deeper into what that means for different scenarios. In the industry, hardware security modules or HSMs typically were these big boxes which you had in banks or secure vaults, which were used to keep secrets, digital secrets. And now that term is now being used even for little hardware security elements which go onto devices. TPM is in this definition is a form of an HSM. So HSM has been kind of adopted by the industry, and whenever you want to talk about a secure element which has some crypto functionality and which has some secure storage, you probably would call it an HSM at a high level, and then you would talk about each protocol or technology. Now, the point here to remember is that the presence of an HSM, TPM or whatever, the presence of an HSM on the device does not mean anything. It's just another feature that you have. Unless you build your whole application, the OS uses it, and then whatever is running on the device, everything uses that. Unless that is happening, presence of HSM is as good as not being secure. Right? So it's the use of that hardware which really matters, not necessarily the presence of that hardware. So there are 2 approaches here. Either you can do standalone or integrated. So this is more design. In case you have a processor and you have secure element and they need to grow separately, innovate separately, the design on your left. Otherwise, you do it in an integrated fashion. So when we started thinking about hardware-based security, we came up with a process that we recommend to our partners of how do you select the right hardware for your IoT infrastructure, right? I think that's a big ask that we have often come across by our partners, saying that there is so much security hardware out there. How do I know what to select, right? We came up with this process, and soon we'll be publishing this as well. So the first thing you do is, there are 3 steps. 3 steps is always good, right? So we start with planning, we do some architectural decisions, and we help with that. And then we start execution, we help with that also. So for planning, the first thing you do is you do design assessments. So for example, how automated of provisioning would you want this device to have? Would you like it to use device provisioning service? That actually dictates certain hardware compatibility right out of box. How maintainable should this hardware be? Do you want to be able to update this hardware all the way from the cloud, and it's at scale, and you want to put some new hardware firmware on it? If that's the question, then there are some assessments you'll have to do. So we, in a few weeks, we'll actually be providing more details, but the design assessment is the first step. And then what we recommend is going into risk assessment. So when I do all of this, what are the different risks that I'm taking, right? Or am I avoiding? So like my privacy, what are the attacks there on privacy? How much would the damage to my brand affect me? So what kind of compromises would happen over there? All these are assessments. And interestingly, after this, I'll actually talk about a program which allows you to evaluate that. Then you go into architectural design, and you evaluate different architectures. You evaluate different hardware components out there, and we provide ways for you to understand what those hardware components are. And then it is about execution. In that execution, there is a strategy for OS. Do you want to go for a rich OS? What are the different kinds of OS out there? You want to go for an RTOS. You want to obviously do secure development, secure provisioning, and so on. So this whole life cycle we'll soon be publishing, but just giving you some line of sight into what and how we are thinking about this. Which brings us to DICE, which is a new framework that we worked on in the last 3-4 years, actually, to secure IoT devices. So I'm going to go a little bit deeper into its design and talk about what are the different things it provides and why this is over and above what the rest of the industry provides today. So it is secure by design, and what does that mean? It uses silicon to create hardware-based identities. So the silicon on the device, based on some measurements, creates some identities, which then you use to identify the device. So you'll have to throw away the silicon, which means the device is no longer there, to actually change its identity. It's also hidden. So nobody can actually get access to it. Nobody can read the identity. You only get a certificate certifying that there is an identity underneath. So that's one. Yeah, it's built into the device because it's part of the DNA or part of silicon. We also provide attestation. The key point here is attestation. And that is over and above what many other models provide you. So not just device identity, but you can also use this model to attest your firmware at boot time. So imagine when the device comes alive, the first thing you do is you attest or you check if the firmware that the device would be booting from is compromised or not. If it has changed, the device would generate something, but it would not be able to connect. It would not be able to do a bunch of different things. Right? So that's a property of DICE. And all of this is based on, and then that enables secure boot. It enables remote attestation. So imagine the cloud knows the right state of the device. If the state changes, the cloud does not allow some functionality there or forces an update to the device. So there's a lot of things now you can do with remote identification based on silicon as well as remote attestation. If you want to read more about DICE, here is a URL. Now, we came up with this design, and then we went to TCG, which is Trusted Computing Group, which is the one which actually standardized TPM. And they have now a work group which is working on standardizing DICE. Okay, so let's look at how it actually works. right? So on your right is your first mutable code, as we call it, essentially your firmware. On the left, of course, is where this process starts. Either the device is resetted or starts. And then this flow happens, which is the DICE engine. The first thing that happens is it makes a measurement of the mutable code, so of the firmware. It goes in and measures the number of bytes and some other parameters around that mutable code, firmware, right? It combines that with the device identity, which comes out from the silicon, which is the identity, and creates a compound device identifier. Now, this compound device identifier has two things: the device identity as well as an identifier for your firmware. And this is happening at boot time. And these two get together, and a certificate is generated on top of it, which is then shared, which is then checked against wherever you are keeping your source of truth, which should be in the cloud. And only then you can proceed. And then you use, once you boot, you use that certificate for your authentication with the cloud. So this allows you at boot time to not just identify yourself securely, meaning the device, but also to attest that firmware. So it could be based on TPM for your secret. It could also be based on a number of different patterns. And the firmware or the boot sequence is the mutable code. And as I mentioned, this is part of TCG today. Again, another URL here. Sorry, I'm throwing too many URLs. But another URL here, which essentially takes you to the TCG working group, which is working on standardizing this DICE model. Now, we started this work about 3 years back. And right now, we have two partners, ST Microelectronics and Micron, supporting this hardware. You can buy hardware from these manufacturers who actually, which actually implements DICE. So essentially, if you're creating a new device, today you can actually buy that hardware. But there is one more partner that we add today, I announced that, is Microchip. So today you can also go out and buy Microchip hardware for DICE-enabled security on it. It comes in two forms. It comes in a simple microchip, the one, yeah, pun intended, microchip. So it comes in that packaging, which is an IC, simply put on your device, and it enables DICE on it. Or it also comes as a development kit. They call it the demo kit. The demo kit, which has a bunch of sensors on it, but has the DICE chip on it, which you can use to prototype your environment, to understand how it works. And you can actually order it today, going to that URL, microchipdirect.com. So Microchip is our third partner, which is supporting that. Hopefully, there will be more, but there's now a diversity of hardware from at least these three partners who provide DICE-enabled hardware, which you can use in your devices. Or with this kit, you can actually play around with it today and prototype things on top of it. Okay, so what does DICE do? Right? I'm not going to go into the details of device provisioning service because that was discussed yesterday in a full session. But I'll just talk about what does device provisioning do. Device provisioning service is a new service that we announced a couple of weeks back. DPS, device provisioning service, allows you to connect your devices with zero touch. You do not touch them at all. It simply connects to the cloud, and then based on DICE or TPM, so it supports DICE as well as TPM, and it supports extensibility, which means you can bring in any other hardware model, and it connects to the cloud. The key feature here, one of the key features here is, it is also geo-sharded, which means that if your device comes alive in Europe, and in the enrollment list in the cloud, in DPS, you have defined a rule that if there is a device coming alive from Europe, connect this device to a different IoT hub. If the same device comes alive in the US, connect to a different. It's all about rules that you define in DPS. So that enables you to do zero-touch provisioning, but also do it intelligently based on geo-sharding. It's enhanced security with DICE, TPM, and other HSMs. In the DPS agent which goes onto your device, there is an auth API layer to which you can actually put any kind of hardware. So it's any device which can connect, which is a host of different devices to IoT Hub, goes to IoT through DPS. One thing that we are trying to achieve with DPS is to remove the human error here of copying that code or being there, or even not being able to scale to thousands of devices manually being deployed. So we enable zero touch in the provisioning for that. And then, of course, scaling. So that's really how DICE and other hardware models plug into our services. We enable zero touch provisioning when you can actually detect the identity of the device securely, as well as you can attest the firmware of the device securely. Then you have the opportunity to do zero touch provisioning. Now, one question that has often come up is, how do I choose the right OS and the right client-side software components for my device? Azure IoT Device SDK is open source, cross-platform, and in a number of languages. Some of them listed here: C, C#, Node.js, Java, Python, and we are constantly increasing that list. All the features that we ship are simultaneously shipped to all of these SDKs. These are libraries. They're optimized. For example, the C library is optimized to go on a very small board with with a bare metal, not even an OS on it, so it can run there. So we have optimized these for different scenarios. We also support all major operating systems, including Linux and Windows, so wherever you want to put, as well as RTOS, so real-time OSs. As long as the library can execute on it, it would work, as well as bare metal MPEG. So we also support devices which do not talk IP, right? They cannot talk directly to Azure IoT Hub, but they can go through a gateway device. And we have a gateway SDK out there already, the IoT Edge Gateway SDK out there. And we are working, if some of you were there in the 9 o'clock session, we are working on IoT Edge, which enables you to do protocol translation. Imagine that a Bluetooth device connects to a gateway device or an edge device, and the edge device onward transmits the data up to the cloud or does some processing right there on the gateway. So we also support that. Now, when you're thinking about selecting the right operating system, obviously Windows IoT Core is one option, and it is one of the more secure operating systems that you can actually get your hands on. Security is built as part of the OS and is updated, so if you enable that, it would be updated. Your OS would always be kept current there. Some of the advanced features that Windows IoT provides: on the left side, the circle on the left is the OS, on the right is the cloud. If you read that, device protection is extremely important. It's based on a TPM. So remember TPM, DICE, so TPM is supported, which means this can use zero-touch provisioning. It gives you health attestation for the device. It gives you secure boot, boot locker, BitLocker. All of these are features which makes your device more secure. So that's one choice of an operating system. In addition to all the other operating systems we support, this is one secure way of doing it. Then we do, Windows IoT does also threat resistance. So things like Device Guard, Firewall, Windows Defender are all defense in depth. You create that defense by using all of those. So that's one choice. Of course, we have talked a lot about the right side, which is the cloud security that we provide. Okay, so let's now switch gears a little bit here. We talked about how hardware security is there. We talked about how hardware security can help you do zero-touch provisioning, how you select the right hardware, and the different things that we are doing in that space. I talked about Microchip as being one of our new partners in addition to ST Microelectronics and Micron for silicon. Let me now start talking about how do you evaluate your IoT security. Imagine that you already are thinking about your end-to-end infrastructure. Here is a way, and this again is a white paper, I'll give you a link here. Here is a way to actually evaluate your end-to-end IoT security. So the first step is to consider threats. I'll go into details. Review the consequences. Each step, each threat has a consequence. Right? When something bad happens, you lose something. You lose data, you lose privacy, you lose a bunch of different things. We'll talk about those. Then you select the right evaluation strategy, and I'll go into details of how and what we recommend. And then you choose a platform and a partner to execute the strategy. I'll go into more details. So let's talk about the first. Here is just 6 of the threats that I've put here. In that paper, which I'll give you shortly, we have something like 250 threats that we described there. And these threats are not new. I mean, we are not the authors of those threats. These threats are known in the industry. We simply have put them all together so that in one place you can see them. And some of these are over here. We are even thinking about hijacking of the device, both virtually as well as somebody takes it away. We're talking about natural disasters. So when natural disasters happen and your device is in there, what are the protections you need to put in place so that you can be protected from bad things happening from the device? We talk about physical attacks. We talk about hijacking. So all of these are threats that we provide more details. But the link between these threats and the consequences is interesting. Each of these threats might lead to a set of consequences. These consequences can be divided into three parts: consequences to the company, consequences to your customers, and consequences to infrastructure. Right? So as an example, loss of data is a consequence that is on the company. Damage to brand, financial loss, all of these are consequences when bad things happen on your infrastructure. To your customers, things like service disruption. You might lose customers because you are not disrupting their workflows. And infrastructure, there's loss of life in there. There is loss of or environmental damage in there. So those are the kind of consequences that might result when people attack your IoT infrastructure. So what we do is we provide a way to map the threats and consequences to these evaluation strategies. And these strategies are, again, known. For example, end-to-end threat modeling. Under what circumstances should you do end-to-end threat modeling, and at what time in the life cycle of your project? And this Gantt chart actually describes that. When should you do deployment reviews? When should you do network traffic analysis, and so on? So we provide all of these details about when do each of these evaluation strategies needs to be exercised. As I promised, here is the paper, ak.ms/IoT security eval. That gives you details of this whole strategy for evaluating your IoT infrastructure, if you are either building it, if it's already there, and if you want to just evaluate to see where it is. Now, this is good. So you could actually go in and evaluate that, but many times you need specialized people who specialize in a bunch of these evaluations to partner with so that that evaluation can happen. For that, we started a new program, which is called the security program. We started it last year. Actually, it will be a year now. And that program essentially is to work with a bunch of third-party partners who are experts in their own security areas, and then make sure that they have the right knowledge, and then make sure that our customers are talking to them. So we are really the matchmakers here. So this is a partial list over here, but each of these security partners specialize in something in IoT infrastructure. I'll give you examples. Praetorian specializes in code analysis and silicon analysis. If you have a silicon device and you want to see if there are any back channels open on it, obviously you could try to buy an oscilloscope and a spectrometer and put it next to it. Not recommended. Or you could go to these experts who have the infrastructure to actually run it through and tell you what are the attack vectors that are open on this device, on this silicon, right? So, and so on. So there are a bunch of these. I'll just pick one up in addition to that. I'm looking for that. Kasaba does a lot of code analysis. They do white box, black box, they run through the code, they do protocol fuzzing, and they would come back and tell you that this is secure and this is not secure. CyberX does a lot of proprietary protocol fuzzing. So if you have Modbus or CAN bus and you want to fuzz that and get some idea of what it means to be secure, these guys know that business very well. So in short, we chose these partners and more on the, I'll give you a URL. I'm giving too many URLs today. But I'll give you a URL here, which would take you to a place where you can discover these partners and think about evaluation of your IoT infrastructure. Oops, I'll give you later on this URL. Okay, so as I mentioned earlier, this work is is not complete at all unless we work also on standardization, unless we also work on policy and regulations. So I'm going to give you a glimpse of what that is, just so you know where we are going with all of these different things. This is my big concern here. Standards and regulations take years from the start to the end, right? And that is my call to action, that we need to shorten that. So, and the reason is because the velocity of innovation, how quickly we all are innovating, is very fast, and how quickly standards and regulations adapt to that innovation is very slow, right? And that creates a problem, because when I say we need standards, if I adopt standards which are already standardized for the last 10 years, I'm actually taking you back 15 years, right? Because it took 5 years for that to become a standard. But if I tell you that this is something that you need to adopt and it's being standardized, and you say, no, I only want standardized, then obviously you go back. So there is a conversation to be had in terms of what are standards and how do we deal with this slow speed, slow velocity of standardization. My favorite example here is the example of a motor car, right? So the motor car was invented somewhere in the late 19th century. And from then to its mass, adoption, it took about 70 to 80 years for it to be adopted. On each road, then you could see cars and so on. And so the regulations, standards, they all, the society moved with that innovation. Society was able to adapt to it. There were new regulations. The street lights were invented and so on. And the luxury was there. But today, in this very innovative environment where we live in, take the example of Uber. From invention to mass adoption, less than 6 months. Less than 6 months. And they did not wait for all cities and all countries to regulate around it. They go in, they fight it out. Some cities throw them out. They fight it out, and then they adopt. I'm not saying that is the model we have, but I'm saying that is the difference in the velocity of regulation versus the velocity of innovation. And we need to think about that. So we work extensively with governments. Because we are connected in all these places, we try to talk about this. We try to take this opinion to all people who are responsible for making those decisions and making those regulations happen and policy happen. So we do a lot of this across regions, across countries. The regulations in one part of the country is very different, of the world is very different from another one. And so we try to work across those. Now, one thing that we are doing, and this is something that directly plugs into that evaluation strategy, into our security partners, is understanding that if I go in and do or try to do an evaluation, what are the standards out there which I could use? Right? There are a bunch of standards out there for cybersecurity. Cybersecurity has been out there. People have written a bunch of standards, frameworks, so on, which can be used. But they are not IoT standards. A bunch of those that I show here are not IoT standards, meaning the cyber and the physical is not coming together. They're not talking about safety. They're not talking about reliability. They're only talking about keys and key management, which is important, but it doesn't bring the whole thing together. So based on that, we realize that there is a gap in the industry where holistic IoT standards for IoT security are not out there. So then we started working on a standard which we are calling the security maturity model for IoT, and not for cybersecurity. There are a bunch of maturity models for every conceivable thing, but not for IoT security, and so we took that up. Together with our partners, this work is being done at IIC, which is the Industrial Internet Consortium, and we have a bunch of partners there, all big ones, manufacturers, technology companies, and so on, and we are writing this new standard of what does maturity in IoT security mean. So I'll give you an example of, and this is just an example, not necessarily the rail standard, and it's extremely abstracted. If you look at the standard today, if you're a member of IIC, you can see that. It's much more detailed there. But we are defining 5 levels of maturity. Level 0 is not secure at all. Level 5 or level 4 is extremely secure with biometrics and multi-factor auth and so on. And then anywhere in between. For example, level 2 would be secure storage on the device, hardware-enabled unique device ID, and so on. And then what we are doing is we are linking those maturity models to scenarios. And we are saying as a suggestion that if you are a nuclear plant or a critical infrastructure like grid, you'd rather be 3 or 4, perhaps 4. But if you are a consumer device which sits on somebody's hand, then perhaps level 2 is sufficient. Right? So we are giving a theoretical framework so that people can look at it, and it's industry standard, industry accepted, where people can say, okay, I think I can reason through my security, and I can reason through this. I am right now at level 2. Because I'm a nuclear plant, I need to go to level 4. And here is a roadmap of how I go from where I am today to where I need to be. And we are calling it the security maturity model. Initial version is going to be released soon in the next couple of months for comments. But we have been working on it for almost a year now with IIC. Standardization will take time, but we believe as soon as the initial comments are done, we should be able to start applying it in different industries and adapting it to those industries. That actually brings me to this slide. I'm sure if you have been following what Microsoft and Azure does, you would have seen this picture. This is really the huge compliance footprint that we have. And compliance is security, privacy, and all of that together. So there are some global standards that Azure IoT and Azure generally conforms to, including ISO and so on. There are some US government standards such as NIST, HIPAA, sorry, not HIPAA, but IRS and FedRAMP and so on. Then there are some industry ones, and HIPAA is one of them, and they are we comply to all of those. And then there are some regional ones. In each country, there are certain standards that we have to comply to. For example, in Canada, we have to apply to their privacy laws. Spain, there is, and so on. So there is a bunch of those compliance standards that we comply to, and constantly we are audited against. And so our infrastructure remains compliant. Which actually brings me to the end. I'll again state what I stated earlier on. Microsoft is leading in IoT security. Why I say that is because of the bunch of work that we are doing to enable secure device management, secure device provisioning, working on the cutting edge of IoT hardware, secure hardware, including DICE, and working with silicon partners so that it's widely available, and empowering our customers, our partners, to not just know about security, but empowering them with programs and standards and regulations and all of that so that they can actually design, and together we can design the right secure IoT infrastructure. Which brings me to the end of the talk, and I'll be happy to take any questions. We should have had a coffee break in the middle somewhere, right? Yeah, please. Right.
Is there a mechanism in your portal where if I haven't seen it for 6 hours or 12 hours and reconnect, I'm able to put a rule in and say, well, it's been too long since I've seen it. It's possible to put it to another device?
Yeah. So just to repeat that question, is there a mechanism in Azure where you could write a rule or some logic on top of whatever is coming in, a device coming in, and then the rule might just be, I haven't seen you in a day, a few hours, and maybe there is something wrong. You know, that's one example of a rule. So our device registry in the cloud, which essentially is the source of truth for all device authentication, has an API layer on top of it. So you can actually subscribe to an event which tells you when the device comes in, and then you build your rule engine on top of it. So that, at the API layer, that is possible. Is this specific scenario implemented today at the user experience layer? No. But at an API layer, you could always write that rule on your own. Any other question? Well, thank you very much for coming over, and thank you.